Welcome back to 5.3, where here we're going to be taking more of a technological approach, talking about finding real roots by graphing. As mentioned in the previous video, we learned how factoring can help us solve for polynomials. So although they look pretty bizarre, going up, going down, going up like that sometimes, we can still consider there to be solutions, sometimes more than two. In this case, we would have three. So although factoring is helpful for this, sometimes it's better to just use a graphing calculator, get a feel for what theirs are all looking like. So we still apply the same rules where we want our polynomial set equal to 0. From there, then we'll start to graph. So first, let's move all of our terms to the same side. I think it'll be easier to move 3x squared and negative 2x to the left, because this already has a positive leading x cubed term. So let's keep it that way. Let's move 3x squared over. Let's add 2x, take these both to the left side, leading with 2x cubed, minus 3x squared, plus 2x, plus 5, where this is now set equal to 0. So once it's set equal to 0, we can then graph this out and then get solutions, which again is our goal, because as mentioned in the context, we're trying to find the real solution. So these are definitely numbers we can get, definitely numbers that we can graph, so let's do this. So we're first graphing to 2x cubed. We're then subtracting 3x squared. We're then adding 2x. We're then adding 5. So let's see what this looks like. We've talked about end behavior, we've talked about how these will look, but we've only seen these graphed so many times. And I think if we zoom out even more, we'll see how crazy this looks. This looks like more like a parabola. Oh, all right, yeah, I needed a 3. There we go. That'll make it easier. All right, so now we're getting somewhere. So let's zoom in, see where our solutions are approximately. Get closer. Looks as if we're only going to have one, so I think once you get close to this, same kind of song and dance that we've done with before, we're getting a 0. We want to measure left bound, we want to measure right bound, get that approximately negative 0.84. So this is going to occur when x is approximately negative 0.84. So collectively only one solution from the looks of it. I'll give you a moment to try the next one. Think about what this needs to look like. Well, first, again, make sure your polynomial is set equal to 0. This is where I see students trip up the most. So let's really make it a point to do this every time we're graphing these out. Make sure your polynomial is set equal to 0. So let's move x over, let's add 1. We'll eventually get rid of x here and add 1. So now we have x cubed plus x squared minus x plus 1, and this all equals 0. All right, so let's let this one rip. Let's clear this out. We have x, we're cubing it, we're adding x and we're squaring it, we're subtracting x, we're adding 1. So it's looking pretty groovy. Let's zoom out just to make sure that we have good understanding of how this works. Yeah, that's about right. So let's take this further. Let's get this 0 with the left bound, right bound, approximately negative 1.83. And that's good. So again, only one real solution. The next two are a little wordy, but I think if you think them out, they're pretty simple to kind of map out. So we're looking for 3 consecutive even integers whose product is 3 times their sum. Well, we know that terms are even if they're divisible by 2. So whatever number it might be, it's even because it's divisible by 2. So let's say that this is the first number. And ideally, if it's consecutive and even, then the next number would have to just add on 2. Third number would have to add on 2 to this, so this would have to be 2n plus 4. Eventually, we'll find out what the first number is, but we don't quite know yet. So we know 3 consecutive even integers whose product is 4 times their sum. So let's first find the product. So if we have these all multiplying together, this will take a little bit of time. So you could say that this is 4n squared plus 4n. If you multiply it with all this, this should then get you 8n cubed using foiling here. We're then adding on 16n squared. You're adding on 8n. Finally, you're adding on 8n squared and then plus 16n. And they're saying that this product, so the product of all these, this is already done on the left. And they're saying, when is this equal to 4 times their sum? So when is this equal to 4 times the sum of all of this, which would be, the 2n plus the 2n plus 2 plus the 2n plus 4. A little hectic, but just combine like terms. So this is going to be 4 times 2n, 2n, 2n times 6n. You have that 6 also. So eventually this equals 24n plus 24. And so this looks pretty bizarre, but we can definitely graph this out. So let's move some of these terms around. If we subtract 24n and 24, that gets us here. Let's keep 8n cubed. We're still holding on to 16n squared. We're still adding 8n squared. If we deduct 24n, this is going to deduct 8n. And then also subtract 24. This now equals 0. So pretty intense to graph this out. So again, graphing on a calculator is going to be helpful. Let's get this one in there. Let's clear this out. So let's see, we have 8. Instead of x, instead of n, I'm going to use x. We're then adding on 16 x squared. We're adding on 8. Yeah, you can combine like terms. All right, so let's just combine these. Cool, that's fine. Better late than never. So I'm going to combine the 16n squared and the 8n squared and just say that that's going to be 24x squared. It's a good catch. We're still deducting 8n, and this is still going to subtract 24. So when we graph these out, let's see what we got. Well, we know that this has to be even, so we're aiming for where it's greater than 0. So let's see if we can get the 0 that's on the positive side. So it's saying when x is 1. So ideally, if x is 1, that means that 2 would be the first one. So this is saying that x equals 1 is one of your solutions. But as far as answering the context, if you take where n is 1 and plug it back into here, you'll see that your first number is 2, your next number is going to be 4, your next number is going to be 6. So these are your 3 numbers, actually. It took a little bit of time to get there. Could have just guessed and checked, honestly, but I think it's cool to see how you could use polynomials in a context like this and graph them out and get a solution.